Now we start with helium neon laser. Gas lasers are the most widely used lasers. They ranges from the low power helium neon laser used in the college laboratory to a very high power carbon dioxide laser used in the industrial applications. These lasers operate with the rear field gases as the active media and are excited by an electric discharge. In this gases, the energy level of the atom involved in this ionizing process are narrow and as such as require sources with the lamp. The wavelength to excited atoms. Finding an appropriate optical source of pumping poses a problem. Therefore, optical pumping is not used in the gas laser. The most common method for exciting the gas laser medium is by passing an electric discharge through the gas. Electrons present in the discharge transfer energy to the atoms in the laser gas by collision. The first laser was helium neon laser was invented in 1961. Now, what is the construction? The diagram of a helium neon laser is shown in figure. Helium neon lasers consist of a long discharge tube filled with a mixture of the helium and the neon gases in the ratio of 10:1. Neon atoms are the active centers and have energy levels suitable for the laser transition, while helium atom helps in the exciting the neon atoms. Electrodes are provided in the discharge tube to produce the discharge in the gas. They are connected to a high voltage supply. The tube is hermetically sealed by the inclined window arranged in the two ends. On the axis of the tube, the two mirrors are arranged extremely, which from the Fabry-Perot optical resonator. The distance between the mirror is adjusted by m lambda by 2 such that the resonator supports the standing wave pattern. Helium neon laser employs a 4-level pumping scheme. The energy level of the helium and neon are shown in figure. When the power is switched on, a high voltage of about 10 kilowatt is applied across the gas. This is sufficient to ionize the gas. The electrons and the ions produced in the process of discharge are accelerated towards the anode and cathode respectively. The energetic electrons excite helium atoms through the collision. One of the excited level of the helium F3-2s is the 20.61 electron volt above the ground level. It is a metastable level, and the excited helium atoms cannot return to the ground state through the spontaneous emission. However, it can return to the ground state level by the transforming its excess energy to the neon atoms through the collision. Such an energy transfer can take place when the two colliding atoms have identical energy levels. Such an energy transfer is known as the resonant energy transfer. One of the excited level, neon E6-5s, is at 20.66 electron volt, which is nearly the same as the level of F3 of the helium atom. Therefore, resonant transfer energy can occur between the excited atoms and the ground level of the neon atoms. The kinetic energy of the helium atom provides the additional 0.05 electron volt required for the excitation of the neon atoms. Helium atoms drop to the ground state after the exciting neon atom. This is pumping mechanism is the helium neon laser. The role of helium atom is to excite atom to cause the population inversion. If the diameter of the discharge tube is increased, the probability of the collision of the atom with the wall decreases and the neon atoms tends to accumulate at the energy level E2. Due to due course of the time, the atoms are no more available in the ground level of the further excitation. Therefore, the laser is to operate. The helium laser operates in CW mode and is widely used in laboratory as a monochromatic source. Okay, thank you.